Let's take a look at number 2 from synthetic division number 2. So I'm going to first use the rational root theorem to list all the possible rational roots. So I'm taking factors of the constant, which is 1 and 2, numbers that evenly divide into 2, and then I'm going to do the same thing for the leading coefficient. So what are the factors of 12? And now I'm going to come up with all of these, and sometimes this is confusing for students. So 1 over 1, okay, so it could be positive or negative 1. 2 over 1, positive and negative 2. Now I'm going to switch the denominator. 1 over 2, both positive and negative. Well, 2 over 2 just reduces down to 1, so I don't need to list it. I'm going to move on to this third denominator. 1 over 3, both positive and negative. 2 over 3, both positive and negative. Moving on to the next denominator. 1 over 4, positive and negative. And 2 over 4, when I move on to the next denominator, well, 2 over 4 just reduces to 1/2. Moving on to the next denominator. I have 1 over 6, positive and negative, and then I have 2 over 6, but 2 over 6 just reduces back to 1/3. Then I have 1 over 12, which is not listed, so positive 1 over 12 and negative 1 over 12. And then I have 2 over 12, which reduces down to positive and negative 1/6. Now, I'm always going to try first to see, do any of the integers result in an output of 0 when I test them using synthetic division? Let's start by testing positive 1. So remember, I'm going to D-mama, drop down, now multiply and combine, multiply and combine, multiply and combine. That tells me that 1 is not going to be a root to this equation. Okay, D-mama, drop down and multiply. Add and multiply. Add and multiply. And again, this is not resulting in a 0. We're going to keep moving on here. Hopefully one of these 4 works. It's going to make our lives much easier. 2 times 24, 2 times 12 is 24. Add down to come up with 16. Multiply to get 32. Add down to get 25. Multiply to get 58, add down to get 60. No. All right, let's try this one. Drop down, and then I'm going to multiply to get a negative 24, combine to get a negative 32, multiply to get 64, add down to get 61, multiply to get a negative 222, combine to get a negative 220. None of those work. So what do I have to do next? I have to come back up here. I know that I'm testing possible roots here. I just need to find one that works, and then I can use factoring as a way to solve it, or quadratic formula if it's in that form of quadratic of the degree being 2. I'm going to now try 1/2 and negative 1/2, which may not be pretty. Let me set it. All right, bear with me here as we go through this. We're going to drop down the first number. What is half of 12? Well, that's easy. Half of 12 is 6. Combine to get down to get negative 2. Now, what's half of 2? Well, half of 2 is 1, and it's negative. I add down to get negative 4. What's half of 4? Well, half of 4 is 2, but when you multiply, it becomes negative. And now I combine to get 0. Let me do that one more time if I'm losing you. Okay, so D-mama, drop down to get 12. 1/2 times 12, which means 12 divided by 2 is 6. Combine to get negative 2. 1/2 of negative 2 means negative 2 divided by 2. Well, negative 2 divided by 2 is negative 1. Combine to get negative 4. 1/2 of negative 4 means negative 4 divided by 2, which is negative 2. And combine to get a 0. Amazing. Now, what do I do with this information? So I'm going to write this. 0 equals negative 4, negative 2, and 12. Has no x's, has 1x, has 2x. Okay. Now, right away, I can see that 12, 2, and 4 are all divisible by 2. So I'm going to factor out of 2 to get 6x squared minus 1x minus 2 equals 0. It may be easier now to solve this quadratic portion using factoring if possible. If not, I will I will defer to using the quadratic formula. Okay, what multiplies to give us a negative 12 and combines to give us a negative 1. That'd be negative 4 and positive 3. But because the leading coefficient is not a 1, I do need to go back to thinking of the AC plus B method. So I have 6x squared minus 2 equals 0. Give myself some space here. I'm going to plug in a negative 4x and a positive 3x. And let's see what we got here. Okay, factoring by grouping. I can factor out at most a 2x. Now I'm left with 3x minus 2. Making sure I've done that right. And 3x minus 2. What times 3x gives us 3x? A positive 1. And if I multiply it times negative 2, I come up with the same part. So they both contain a 3x minus 2. The other is a 2x plus 1. I'm going to set each of these factors equal to 0 at this time. I'm going to solve. So I'm going to add 2 to the opposite side and then divide by 3. And I can see another one of the rational roots is a positive 2/3. A positive 2/3. I'm going to subtract 1 to the opposite side, divide by 2, and I can see that the third and final root is a negative 1/2. So I have rational roots of 1/2, negative 1/2, and positive 2/3 for problem 2.